Hi everyone! Today I'm going to teach you how to solve for the product of sum and difference of two terms. Let's take the quantity of x plus 3 times the quantity of x minus 3 as our first example. Obviously, the first binomial is the sum and the second binomial is the difference. And we have here two identical terms, x and 3. In my previous video tutorials, I taught you a method that you can use in multiplying binomials, and that is FOIL method. I hope you still remember it. In this case, if we do FOIL method, we will get x times x, right? First term times the other first term, that's x squared. And then the outer term, x, times the other outer term, which is negative 3. That will give us a product of negative 3x. And then inner terms, 3 times x, 3x. 3 times negative 3, the last terms, will give us negative 9. Now we have here x squared minus 3x plus 3x minus 9. But take note that negative 3x and positive 3x are like terms. Okay? And if we're going to simplify this, we will have x squared minus 9. Now take notice that the x squared here, the first term of the product, is actually the square of the first term, which is x, right? X times x, or x squared, is x squared. And then we have here 9. 9 is actually the square of our second term, which is 3. 3 squared is 9. Okay? This will then lead us to a conclusion that the product of the conjugates, the quantity of a plus b times the quantity of a minus b, is always the square of the first term minus the square of the second term. I repeat, the square of the first term minus the square of the second term. So that means to say it will never be plus. It will never be a sum. The product of the quantity of a plus b and the quantity of a minus b will always be the difference of two squares. Now, let's have our second example. Multiply the quantity of 3x plus 2 times the quantity of 3x minus 2. Now, in this case, we have two identical terms, 3x and 2. And remember the pattern. We have to square the first term first. Okay, so we have here 3x squared, the quantity of 3x to the power of 2, and that is 9x squared. Then we put minus since it's always minus. And we square the second term of the second term of the binomial, which is 2. 2 squared is equal to 4. So in this case, the product of the quantity of 3x plus 2 times the quantity of 3x minus 2 is actually 9x squared minus 4. Next example, we have here the quantity of x plus 3 times the quantity of x minus 3. In this case, our first term is x and our second term is 3. So we square our first term first, no, x squared, and then we put minus. It's always minus. I like to emphasize that. And then we square our second term, which is 3. So 3 squared is 9. So the final answer for this problem is x squared minus 9. Uh, expression x squared minus 9. Then we have here the quantity of xy plus 1/2 times the quantity of xy minus 1/2. I know what you're thinking. Now it involves fraction. Okay? But it's still the same pattern. First, we square the first term. And the first term there is xy. Okay? So the quantity of xy. Remember to put it inside an open and close parenthesis, because the tendency is if you'll just put it after y, that means to say the exponent 2 is only for y and not also for x. Okay, but when we say the quantity of x times y to the power of 2, that means to say the power 2 is also for x and also for y. Okay, so again, we square the first term, the quantity of xy to the power of 2, that's x squared minus y squared. And then we put minus, right? And then we square the second term, which is 1/2. And 1/2 square actually means 1/2 times 1/2. So you multiply 1 times 1, that's 1. Denominator times denominator, 2 times 2 is 4. So the final answer is x squared times y squared minus 1/4. Now we're down to our second to the last example. We have here multiply the quantity of 4x minus 4 plus 3y times the quantity of 4x minus 4 minus 3y. In this case, our first term is 4x to the power of 4 and our second term is 3y. And the pattern for the the product of sum and difference of two terms actually tells us the we square the first term, right? So we have here 4x to the power of 4. We put it inside an open and close parenthesis and then square it. Then we have here minus, and then we square the second term as well, 3y to the power of 2. So remember, from here, it's either we apply the product rule of exponent or the power rule of exponent. So remember, we distribute this power to each of the coefficient or variables you see inside this parenthesis. So we have here 4 to the power of 2 times x to the power of 4 times 2 minus 3 to the power of 2 and then y to the power of 2. Then we simplify. Okay, so we have here 4 squared is actually equal to 16. X to the power of 4 times 2 is x to the power of 8 minus 3 squared is 9 and y squared. There you go. So our product for this one is 16x to the power of 8 minus 9y squared. Now let's have our last example. The quantity of 2x plus 1/5 times the quantity of 2x minus 1/5. So here our first term is 2x and our second term is 1/5. And the pattern tells us that we square the first term. So we have here 2x squared minus the square of the second term. Okay. And 2x to the power of 2, if we're going to apply product rule of exponent, this actually means 2x times 2x minus 1/5 times 1/5. Alright? Then we simplify. 2 times 2 is 4. Then x times x is x squared. Minus, so we have here two fractions, multiplication of fractions. So we multiply numerator times numerator and then denominator times denominator. So we have here 1 over 25. So that's it. This is our final answer. 4x squared minus 1 over 25. Allow me to write it clearly. So that's our product for this problem. Thank you so much for watching this video. I hope you have learned how to solve for the product of sum and difference of two terms. See you in my next video.